Okay, so in this video I'm going to be going over the Chapter 5 test review. Number 1 says a circle has a radius of 5 inches. Find the length of the arc intercepted by a central angle of 35 degrees. Whenever I'm finding arc length, I want to turn into radians. And then, so I'm going to do 35 times pi over 180, because remember the conversion to turn into radians is pi to 180 degrees. And then what I do is I multiply by the radius, which here is 5. So I'm going to type all of those things into my calculator. So I'm going to do 35 times pi divided by 180 times 5. And I forgot to tell us to round. On the test I will. I want you to round to 2 decimal places. So this is going to be 3.05 inches because I was given units in this problem. Number 2 tells me a carousel has a radius of 30 feet. The carousel rotates at 3 revolutions per minute. Find the linear speed in feet per minute of animal on this carousel. So, the first thing I want to do is I know it's taking 3 revolutions, so I'm going to take 3 and multiply by 2 pi, because every time it goes around, it is doing a complete circle. And then it has a radius of 30 feet, so I'm going to go ahead and multiply by the 30. Then, again on this one, I forgot to tell you, I want you to round. I'm going to have you round to the nearest hundredths again. So I have 3 times 2 pi times 30, which will give me 565.49 feet per minute. There's no need to worry about converting my units because I already started off in the units I wanted, because I had my radius in feet and my revolutions were already in minutes. Number 3 wants me to find the angular speed of a fan that makes 42 revolutions per minute. When I'm finding angular speed, all I do is I take my rotations or revolutions, and I multiply by 2 pi. So here, I'm going to do 42 times 2 pi. And then this one I can leave in pi, so it's going to give me 84 pi for my final answer. Number 4 wants me to find the exact value of cosecant of inverse cosine of 7 over 25. This is a ratio, not an angle. So I want to go ahead and start off by drawing a triangle. It's positive, so I want this in the first quadrant. Cosine is adjacent over hypotenuse. So I have 7 over 25. I want to go ahead and find the length of this missing side. So I'm going to use my Pythagorean theorem. I have 7 squared plus b squared equals 25 squared. 7 squared is 49. 25 squared is 625. I want to subtract 49 on both sides. Which gives me 576. I want to check to see if I can take the square root of this, which I can. It gives me 24. So then I want to find cosecant, which remember is hypotenuse over opposite, because it's the inverse of sine. So my hypotenuse is 25, my opposite side is 24. And my angle is always, if this was on an x-axis, it's always next to the origin. Okay. Number 5 tells me given sine of theta equals negative 12/13 and cosine is less than 0, find the values of the other 5 trig functions. So I want to start off by figuring out where this is. So I know sine is negative, and then cosine is also going to be negative. And then I want to show these. Remember, sine is positive in the first two quadrants, so sine is negative in the bottom two. Then I want to find where cosine is negative. Cosine is positive in the first and fourth, so cosine is negative here. So if both of those are negative, I have to be in the third quadrant. So then negative 12 goes here, 13 goes here. I want to use the Pythagorean theorem to find my missing side length. So I'm going to have negative 12 squared plus b squared equals 13 squared. Negative 12, remember, is positive 144. Nope, 13 squared is 169. Then I want to subtract the 144 on both sides. I get b squared equals 25. I want to simplify this if I can. I take the square root of both sides. B equals 5. Because I'm going left on my x-axis, this is actually going to be a negative 5. So then I need to find my other 5 trig values. I started off with sine, so I'm going to do the reciprocal of that, which is cosecant. I just flip the fraction. Then I'm going to find cosine, which is adjacent over hypotenuse, so negative 5 over 13. Tangent is opposite over adjacent. That is negative 12 over negative 5. The double negatives means it's going to turn positive, so I have 12 over 5. I am going to find secant, which is the reciprocal of cosine. So I'm just going to flip the cosine fraction. That is going to be negative 13/5. And then I'm going to find cotangent, which is the reciprocal of tangent. I can flip my tangent fraction. I can flip either the original or this one. If I flip the original, I will still have to simplify. So I'm going to flip the simplified one, which gives me 5/12. Number 6 says let P be negative 3, negative 4 on a point on the terminal side of theta. Find each of the 6 trig functions. So this means this coordinate point right here is negative 3, negative 4. My x value is negative 3. My y value is negative 4. I want to find that c value. So I have negative 3 squared plus negative 4 squared equals c squared. That's 9 plus 16 equals c squared. 9 plus 16 is 25. I want to take the square root of both sides. C is 5. So then I can go ahead and start my trig functions. Sine is opposite over hypotenuse, so negative 4/5. Cosine is adjacent over hypotenuse, negative 3/5. Tangent is opposite over adjacent, negative 4 over negative 3, which simplifies to 4/3. Then I do my reciprocals, so cosecant, is flipping sine. That's going to give me negative 5/4. Secant is flipping cosine, which gives me negative 5/3. And cotangent flips tangent, which gives me 3/4. Number 7 says a hot air balloon is rising vertically. The angle of elevation from a point on level ground is 123 feet from the balloon to a point directly under the passenger compartment. Changes from 19.7 degrees to 31 degrees. How far to the nearest tenth of a foot does the balloon rise in this period? So I am trying to find this value right here. And I have 2 different triangles. I have this smaller one down here. And I have this larger one up here. So I'm going to start off with my smaller one that has the smaller angle. I have my horizontal distance right here, and I want to figure out my vertical distance. I will label this y. So this is going to be tangent. I'm going to use tangent of 19.7. The ratio is going to be opposite over adjacent, so y over 123. I want to solve for y. So to do this, I'm going to multiply both sides by 123. And then I want want to go ahead and type this into my calculator, I need to make sure I'm in degrees, which I am not. So I can go to mode, arrow over to degrees, press enter, second mode to go back home. I type this in, which gives me nearest tenth is 44. Then I want to do the same thing for my orange triangle. So I have tangent of the larger angle here, which is 31. And this is y plus x over 123. I want to go ahead and isolate my variables. So I'm going to multiply both sides by 123. I'm going to rewrite this. I have 123. Tangent of 31 equals y plus x. So I'm going to type that into the calculator. 31. Which gives me 73.9. Which is the sum of both of those distances. Then I just need to go ahead and plug in 44 for y. So I have 73.9 equals 44 plus x. If I subtract 44 on both sides, 73.9 minus 44 gives me 29.9, and this was measuring feet. On the back, I am graphing trig functions. It wants me to identify the amplitude, period, key points, and phase shift if there is one. So starting off on number 8, my amplitude is 2. My period is taking the coefficient in front of x and dividing it out from 2 pi. So this is 2 pi divided by pi halves. So I'm going to type this one into my calculator. I don't think I'll give you one that has pi in the period, pi in the coefficient, but it's on the review, so I'll have you guys work it through there. So this gives me 4 for my period, the actual number 4, not with a pi. Then I need to find my key points. So this is taking 4 and dividing by 4, because you always take your period and divide by 4, which tells me I'm counting by 1. I start off at 0, 1, 2, 3, 4 is where I'm going to stop. And then there is no phase shift. So I don't need to talk about that. The key points, since I start at 0, I can use these to label my axis. I'm going to have 1, 2, 3, 4, and it wants 2 periods, so I'm going to count backwards. I'm going to label my y-axis by 1, because I just need to go up to 2. And then I'm going to go ahead and plug in my key points. I want to show me plugging these in on the paper, so I'm going to have 2 cosine pi halves times 0. So if I type this, I want this back in radians, so I'm going to go regular mode, arrow down to radians, and then I'm going to go type this in. So I have 2 cosine pi halves times 0 gives me 2. So I plugged in 0 and got 2. Then I'm going to go ahead and do the same thing for my next key point, which is 1. Which gives me 0. Same thing for my next key point. Gives me negative 2. Moving on, plugging in 3. Gives me 0. I forgot to put the 1. And then I want to plug in 4. Which gives me 2. So this is one full cycle. Remember, these should be curvy, not pointy. I need to go ahead and repeat this, so I'm going to copy this backwards. Remember, it's the same thing as if I picked this up and shifted it over. So I'm going to start here and then work backwards through those points when I'm copying over. I'm going to go to I'm going to go to 0, -2, 0, and +2, and then copy that over like so. Number 9 wants me to graph two periods of y equals cotangent x plus 4. This one has an amplitude of 1. Because there's no coefficients out front. My phase shift is -π4. To find my period on a tangent graph, I'm going to use 0 is less than or equal to, no, just less than, not equal to, the stuff after the word cotangent, x plus 5/4 is less than pi. If I was doing tangent, then I would do -π² is less than the stuff in the middle is less than +π². So I need to know those intervals for the test. I want to solve for x. I'm going to start by subtracting π4 on both sides. π4. So that gives me -π4 is less than x is less than 3π4. I need to find the total distance to get my period. So to do distance, I take my right number and subtract my left number. I'm going to do 3π4 minus π4, which gives me a distance of pi. So that is my period. My key points will start, didn't stay very well. My key points will start at the beginning of the interval, which is π4. And again, like normal, my key points divide by 4. So I'm counting by π4 and starting at -π4. -π4 plus π4 is π4. π4 plus π4 is π². If I can't remember that on my calculator, oops, I can do 1/4 plus 1/4 and turn this back into a fraction, which gives me 1/2. So that would be π² for my next one. Plus 1/4 again will give me 3/4. Wait, I forgot the 0. -π4 plus π4 is 0. Then I have π4, π², and 3π4. If I don't have 5 points by the time I got to the end, you should double check to see what you've missed, just like I did. My two end values will always be my asymptotes for tangent and cotangent. I am going to count by π4 because I have 0 in my interval and I'm counting by π4. So I have π4 here, π², 3π4, and then I'll do -π4. I need two periods again. I can fit a whole period on the left, but I can't fit a whole period on the right, so I'm going to go left more. So I'm going to have -π², -3π4, -π, -5π4, -3π². I'm going to count by ones on my scale for my y-axis. Okay, so like I said, -π4 and 3π4 should be asymptotes, so I already know. Those are just getting dashed lines. You have to draw these for full credit on the test. Then I want to go ahead and plug in my 3 middle values. I am doing cotangent, so when I type this into the calculator, I'm plugging in 0 first. I can't type in cotangent. There's no cotangent button. Remember, inverse tangent means find the angle, not find the reciprocal. So to do this, I'm going to do 1 divided by, because my amplitude was 1, so whatever my amplitude is my top number, tangent 0 plus pi fourths, which gets me 1. So I plugged in 0 to get 1. I'm going to go do the same thing for my next point, which is pi fourths. This one gives me an error, but because I am doing cotangent, tangent at pi fourths is undefined, which really means 0 is on the denominator. When I do the reciprocal of that, it moves it to the numerator, and that's why the calculator is giving me an error. It just finds tangents undefined, and it's like, I can't do anything, and then it stops. So if I'm working on cotangent and I get an error in the middle, this really means 0. And then I'm going to do the same thing for my last point in the middle. Pi halves plus pi fourths. Which gives me -1. So then I have 3 points. I can use this to make the cotangent graph, which curves like a snake. I wanted 2 periods, so I'm going to go ahead and count out backwards so I can have this. And then I'm going to copy those points over. You will again need to draw your 2 full periods to get full credit on the test. Number 10 is asking me to graph 2 full periods of y equals 2 secant x plus 1. I have an amplitude of 2. I don't have a phase shift because there's nothing with this x, but I do have a vertical shift of 1. This is going to move my graph up. So then, because this is a reciprocal trig function, I am going to actually graph cosine. So when I go do all my work, I am going to graph cosine. First thing I need to do is, I forgot to set my period. It's standard 2 pi. So then I want to find my key points. This is taking my period and dividing by 4. So this gives me pi halves. I am going to start at 0 because there's no phase shift, just a vertical shift. And then I'm counting by pi halves. So pi halves, pi, 3 pi halves, 2 pi. So this is what I'm counting by down here. I'm going to go backwards, the same amount. I am going to scale. And then I'm going to plug these into cosine, because remember for reciprocal functions, I graph the reciprocal function first, and then I draw the inverse of that, or the reciprocal of that after I've graphed my original. So I'm going to plug in the cosine. I have 2 cosine x plus 1. When I type this in the calculator, I want to make sure I close off those. Oops, I'm not plugging in x though. I'm plugging in 0. When I'm typing that in the calculator, I want to remember to close off my parentheses. So I'm doing 2 cosine 0, close off the parentheses, plus 1, which gives me 3. I plugged in 0, got out 3. Then I'm going to go do the same thing for pi halves. Which gives me 1. Again, I'm going to go ahead and do this for pi. Gives me -1. I'm going to go ahead and do this for 3 pi halves. Oops, plus 1. which gives me 1. And then the same thing for 2 pi. Which gives me 3. Oops, 3 is right here. Then I want to connect my points. I need 2 full periods again. So I'm going to go ahead and copy this over. Okay, so for these graphs, when I'm doing reciprocal functions, I have asymptotes where the graph goes from positive to negative. So right here, everywhere at these points in the middle is going to be an asymptote. And then I want to curve my graph around those. So if I had a maximum, it's going to turn into a minimum and curve. And I want to draw all of the curves, even if they're half curves. Like so. So my answer is the graph in red, but I need all of the work showing how I got there.